Good evening, everyone. My topic is on the petroleum and mining industry. Um, this is the industrial hazards major paper that I chose because I have some experience in both processing and research of this fine industry. So the figure here, figure one is Nate logo, but figure two here is a vertical rig. This is a type of rig that's used to excavate crude oil um, in basically starting off the process of extracting crude oil. Um, so we're going to start off with the description of the scope of the industry. Then we're going to go into the industry processes, and then I'm going to go through the industry hazards, and then I'll lead into the controls and standards that are in place. So the crude oil extraction process involves, first of all, creating a well. It's called um, creating a well bore. The process involves drilling down into wherever your site is that you believe or you have discovered that there is crude oil there. It involves using different types of well drilling methods. The one that's shown here in figure 3 is the vertical well drilling method. So you would keep on drilling with a certain type of drill bit all the way until basically you reach the point where you know that you can start getting crude oil extracted. Then what happens is a casing is put around the well, and this is usually done using a cement material. Then um, there's a perforating gun which is used to cut out holes in the sands, and this is to allow for the crude oil to float in. When the well production is complete, which actually requires stimulation sometimes by using hydrochloric acid, then you move on to the well production phase. At this stage, what happens is shown in figure 4. Um, um, the the process involves using an injection well and a production well. So what it does is all of the crude oil that is at the bottom is forced to come up using different methods. There is a natural way of doing it, and then there's a way of basically forcing it using thermal methods. Then this crude oil that's basically produced at the well is taken over for refining into the refining part, and that requires transportation. There's two ways of transportation. There may be other ones. The ones I looked at was pipelines and using trucks. Trucks are usually used for smaller amounts of samples. Then basically in refining phase, you use fractional distillation columns and other methods to extract out different portions of um, your oil. You can actually get different parts based on different temperatures that are provided to the crude oil, which can produce kerosene, asphalt, diesel, gasoline. So all of this is then shipped out and marketed. The part that we are concerned with is obviously occupational health and safety. So the statistics show that there was more than 150,000 employees in the field in Alberta. And out of these, 1,848 had disabling injuries after working there. And just in 2016 alone, there was 599 claims, 599 claims in 2017 as compared with 2016. There was 599 more claims as compared with 2016, but this was still the least amount of claims. Um, the other thing is there were more job cuts over the years. There was 19,500 losses in jobs over the course of 1 year. Um, um, but the thing is, the industry has the fourth uh, highest death rate, which is not that much considering that It's out of the nine. It's out of nine different industries. There was only 62 fatalities. So it is relatively less than other industries, but still pretty high. The processes in the industry involve well drilling rigs and drilling fluids, and then casing, as I mentioned, and stimulation using hydrochloric acid. Then there is production, then there is transportation, and then there is refining. So this slide here shows different types of specialized equipment and processes. The first picture, figure 5, shows a specialized rig that belongs to ExxonMobil in Australia, off their shore. And the process is similar in offshore, but it's said to be more complicated. Figure 6 shows a well drill bit. So the specialized equipment comes into the drill bit. It's more complicated, it has more aspects to it when it's associated with offshore or diagonal drilling. Somewhere where there's more difficulty, there's always more specialized equipment required. In figure 7, we see a fractional distillation column. This is the refining part, and basically it shows a schematic of the different um, sections of crude oil that are useful in different areas. So it's used as jet fuel or in cars or on roads as asphalt. Then there's other processes. These involve welding, lifting heavy weights like the workers are in figure 9. And then figure 10 shows a worker in a refinery wearing a hard hat and coveralls and basically taking test samples here. The industry hazards and measures of control. So in terms of hazards, these are some of the major hazards shown from figure 11 to 17. Except for figure 15, which is a solution. Figure 11 shows noise. So noise is a big hazard in the industry all over the place because you're using equipment which is noisy. And anything above 85 decibels, according to OHS Alberta, is not good for hearing. So there needs to be some sort of noise protection in place. So this is usually done through working out how one would get better equipment. For example, changing out noisy fans for less noisy fans, using ear muffs or ear protection as personal protective equipment, and obviously giving training to the employee, which is, so PPE is the last stage, but before that you have admin control. So administrative control in this case would be training or signage. And then in figure 12, yes, there's signage as admin control, but there is also a need of an H2S monitor, which is shown in figure 15, because hydrogen sulfide gas is a poisonous, toxic gas which can kill people anywhere above 300 ppm. It's deadly. So you need to have a hydrogen sulfide gas monitor always to be able to avoid getting sick from working in such an environment. Then figure 13 shows well explosions. These are explosions that take place in the production phase or even in the excavation phase. So refineries have to work out ways of limiting this sort of behavior by using advanced equipment, monitoring, and avoiding dust. The potential for dust, OHS recommends against. It recommends that you control the dust by cleaning the work site often, and then using sometimes wetting agents on the drill bits to help make sure that they're fluid, using drilling fluids to ensure that there is no spark or chance of it. And there is a chance of exposure to mercury spills, mercury shown in figure 14. So to avoid this, the Environmental Protection Agency in USA has enforced certain monitors, and basically using a spill kit is very important too in this situation, according to government of Alberta. Oil tankers are a big near miss in terms of accidents. There was an incident in May 2018, according to government of Alberta, where one person died because of, well, not like an accident basically occurred on the highway involving the oil and gas industry's vehicle. The other thing is psychosocial hazards. The oil tanker the one that crashed might have been because of stress from work or, work-life balance, working alone. All of this stuff plays a role. So there is a need to get a balance on that stuff, and there is a need for legislation, SOPs, and procedures. So this is the sort of stuff I've discussed in my paper. And in conclusion, occupational health and safety in the petroleum and mining industry should not be taken lightly. Trends pinpoint to better management, however, they can still improve over time. Petroleum mining industry requires thorough planning, continuous monitoring, controlling, and improvements to safe work procedures. Um, to ensure all workers stay safe. Safety should be a key part of the business strategy to ensure that the industry meets all of its obligations to all stakeholders involved, specifically its workers, their families, residents, and the government in its jurisdiction. Here are my references. So part one is basically showing the figures. Part two here is showing all of the material that I used to gather the data.